Toda. Animits daar. Beamer. I knew I was coming to Israel, and I know that you folks are always very formal. So I was like, I'm going to wear a tie. That's a good idea. But then I tried Houdini and the rainbow ties, and then this happened. So, sorry. But anyway, who of you have used the following product? This is Outlook, webmail, but the new version, which is currently in beta. Anybody used it yet? I saw someone. There's actually a button where you can try it if you're using Outlook. But it's an interesting product for a reason. Another question. Who did ever play Battlefield 5 or 1? So those two products have something interesting in common. Both are using React, and both are using MobX to manage their state. And that might be quite surprising to you, and you must be maybe like, oh, that must really make you happy. That's kind of true, but there's something that really sparks a joy in me, and that is the following. People that put on really lovely suits. And I can basically go on forever.
Fashion icon.
But my question in the end is, Bruce Lawson, Lama, Kacha, Chazak. So anyway, I want to talk about a few random things you might already know for a long time. But just I want to reiterate them shortly because they're relevant for the rest of this talk. And so there's this concept of pure functions. And pure function is very interesting because it means that like if you pass in the same argument, then it produces the same output. And beyond that, nothing in the rest of the world did change. And they are very interesting because they can be memoized, and more importantly, for optimization, they can actually be substituted. So everywhere in your code base where you have like the sum of 2 and 3, you could immediately put in like 5. You couldn't leave out the whole function call. Something else random. Who likes Texas? Nobody, right? But without them, it's basically impossible to build a really well-functioning country. So you kind of have to have them, although we all hate them. And this was like a fitting picture. So there are also functions that aren't pure, but that have side effects. So for example, if we put in a log statement in the function we saw before, it means that suddenly we cannot substitute this function call away anymore, because it would change the semantics of the application. And so basically we want to say like, side effects are bad, you shouldn't do them. But the problem is that we often need them. We need them for rendering, drawing things on screen, network requests, operating with the file system. And so we need them, but they're hard to test, they're hard to like control and isolate, and you need to stub all kinds of APIs to work with them in test. It's annoying. But the point is that like without them, it's impossible to build a meaningful application. If your application cannot output anything, what is the point of it? It always needs to store something somewhere, show something on your screen, visualize something. So without them, it's impossible to build a meaningful application. Back to the pure functions. Is this function pure or impure? It filters over a bunch of to-dos and then says how many of them are remaining. And by looking at this function, you cannot tell. Because it depends on what the, that doesn't work, what the parameter is doing. Is it an immutable object? Then this function is pure, because then the output is perfectly predictable. If the to-dos object is a mutable thing that like could change over time, then this is an impure function. The problem, however, is like, if this to-dos object is immutable, it does make it more simple to reason about this function specifically, but it means that we pushed just mutability into some other place. Because in the end, there's always some place where there's mutability in your application. Otherwise, you can't have state. The meaning of state is that things can change over time. Sometimes I hear people talk about the concept of immutable state management. It doesn't exist. There's state management with immutable values. But state is always about mutability somewhere. So if you're using, for example, Redux, the Redux store itself is mutable so that you can listen to it and change what it's storing. So state requires mutability. And again, like with side effects, without mutability, it's impossible to build a meaningful application. So mutability and side effects, we hate them kind of for very good reasons. They kind of the root of all evil, the root of all complexity. But on the other hand, they're also at the heart of every valuable process. So what is state management? State management is no more than controlling the mutability and the side effects of your application in a meaningful, more organized way. It's just trying to make life better for problems we already have. Another side step, reactive programming. There are many, many different definitions about what reactive programming is. But here's my take on it. Reactive programming is specifically about controlling side effects. There's an interesting definition by Heinrich Apfelmus. Awesome name, I think. The essence of functional reactive programming is to specify the dynamic behavior of a value completely at the time of declaration. That sounds a bit fake, so let's give a quick example. So often we are managing our side effects in our application in a bit imperative way. So for example, we are printing the state of how many times there was clicked, and we want to debounce that, and then we introduce state like when the last click was, and then we have all this imperative logic to take care of this. And so there's a lot of moving places in here. A lot of codes being stateful, being hard to test. So with a library like ArcGIS, we can make that better. There's still a side effect in here, but it's just a smaller part. We organized it in a better way. And the other parts, they are now easier to test. So it's just about controlling it better. Again, an entire change of subject. And this brings me actually to the actual talk, and that's the question, where does state live? And in this talk, I'm going to use React as an example, but basically the question applies to any technology you use to build your application. And so let's start with the simplest case. Let's say that you have a React component or component in any other tool, and it might have local component state. And since hooks are hyped currently, let's use hooks this time. And for those who didn't see hooks, here's a 10 seconds introduction to them. There is this magic function, useState, and you give it a value, and then it returns you something, a tuple, which returns you A, the current value, so that's basically the value you just put into it, and B, it returns you a function. And a function, that's the interesting part, because if you call it, and you give it a value, then that's the new value that will be stored. And then it will also cause the very same component to render again. And because that component is rendering again, this useState thing is called again, and it's going again to return a tuple, but this time it won't return you the initial value. No, it will return you the value you passed in previously. Now, if you're not used to it, I can see why you're thinking, wow, that's an awkward model. But actually, it's pretty convenient to work with in practice. It's very interesting. Anyway, so I did build a demo for that. And I'm going to try to switch to the other window, but I'm not used to Mac, so anything can happen now. Okay. So there are some bruises over here. And the idea is that I can pick up any of them and just drag them around. Take your time. There will be more later on when we go back to the demo. Be prepared. And so, what does that application basically look like? Well, I had actually 5 demos for this talk, but now I just uploaded one for this one. So in the initial demo, you would only see 2 circles. And that's because in our application, we're calling the circle component twice. And then that component is using useState and uses a drag library. And the handler of the drag library just calls the setCircle function to update the local state of the circle being stored. So that's why the drag and drop works. And so React hooks, they are kind of a neat minimal abstraction to introduce local state in a component. As you saw, the function is like super side effectful because it remembers how you called it last time. But it's nice because it creates a nice black box of your state. And if you look at it from a conceptual point of view, and this is your component tree, it means that if you are dragging this circle around, then that circle is being repainted because it owns the state and it redraws based on that. Now let's take it a bit further. Let's add a bunch of new features. For example, like being able to add new circles to this application. Or exchanging changes with a server, like sending the circles to the server, but also like receiving them. Maybe it's a multi-user application. So what would that mean? It means that you would like introduce a component that has owns a collection of those circles. And it also means that you have to manage some side effects, like setting changes and receiving them. And so, now, back to the same demo, because that is all happening in this demo. So every 5 seconds a new bruise appears. Imagine happening that in the real world. And also the changes are sent to the server, and they're arriving there. The interesting thing is, like, how does that work from a code perspective? So you can imagine that, like, when you capture the state of a set of circles, it might look like this. In this case, I used a map with circles. It could also have been an array, doesn't really matter. And so they stored under their own ID and they capture the coordinates. So this is now the entire state of my application. And then I wrote a reducer that has 2 actions available. One is move and the other one is add. And so I'm spreading out objects, and that's a lot of work. I'm not even sure if this is correct. But anyway, if you're like, oh, that's a lot of code, you can also write it like this. This is using the Immer package, which is using proxies, and gives you a mutable API to do immutable stuff. And actually, John Lindquist was going to talk about that at this time, so that's why I now share it quickly with you. But it's totally unrelated to my talk further. But it's really cool. Try it out. Anyway, so you can imagine that, like, our app component at the root now is going to create a circles component. And the circles component is now the one which is going to own the state. So it uses the reducer I just defined and the initial state. And then I get back the current state and the dispatch function so that I can execute the actions. At that point, I can create basically the event handlers that dispatch the relevant actions and pass them down to circle components. So I'm looping over the circles in my state, and for each of them I pass the state of a specific circle to a specific circle component. That also means that like the circle component itself becomes simpler because it already receives all the data and the event handlers, and it doesn't have to manage any state of its own because that's moved to the parent. And there's one interesting thing here I want to point out is that we can also memorize this function. We can treat this component as being pure because since we are using immutable state, we know for sure that if we get the very same circle, we don't need to re-render. So that's great. That's a nice optimization. I told you that we also want to introduce some side effects. So here are the two side effects. One is that once a drag ends, so not while we are dragging, but when it ends, we want to send the updated state to the server. And secondly, we also set up a socket connection to the server and receive those changes. The implementation of that isn't relevant, but what's interesting is the wiring. So because this circles component owns the state, we have to give that dispatch function to be able to add new circles to that listener. Well, the same demo. So conceptually, what we did is we moved the state up to the tree. So those circles don't own their own state anymore. No, it moved up to the circles component, and the others just receive them. That also means that, like, if you are moving a circle around, then since the state of the owning circles component owns a state, that's the one that needs to recompute and redraw and then send all the relevant circles down the tree again. So now we have two components re-rendering instead of one before. But the cool thing is, of course, we can now also add new circles. Let's add another feature to this application. Let's add lines. I know, this gets really Bruce fancy. And so you can imagine that like the state we start with now gets a little more complicated. So our initial state is a set of circles, we saw it before, and a set of lines. And each line has only two properties, the ID of the circle it starts and the ID of the circle it ends. So that's straightforward enough. But then we also need to reflect it in our UI. So let's introduce a component that draws all the lines. And then we figure that to draw the lines, we need to know about the circles. So the lines component needs to have access to the state of the circles, right? Otherwise, we don't know where they live. So to fix that, we can take two different approaches. So to render a line, we need to know about the coordinates of the circles. So what we could do is every time a move action is fired, we go through the state and we also copy those coordinates to the relevant lines. I think that's a bad idea because that introduces a lot of redundant data and expensive actions. So let's do it differently. Let's derive those coordinates during render. So you might be wondering, does this also mean that we have to move the state again to a different component? And yeah, the answer is yes. So every time we introduce a new feature, we have to put our state somewhere else. I think that is awkward. So one conclusion you could draw is that black boxes are really good for encapsulation, but it also makes sharing state really hard. And probably most of the state you have in your application is kind of local and it's perfect fine to black box it. But there's also the state where your whole application is about, like in this case circles and lines, but it could also be orders or messages or profiles or users, that come back in all different kind of places. And so if sharing is hard, then that complicates things. Anyway, so we are improving our application again, and now all the state lives in the app component, so the root one. It's just moving code, it doesn't change too much, circles are still the same. And we also introduced a new lines component, which is receiving all the lines and all the circles, because we need to compute the coordinates. And so then it gets interesting. So the lines, well, they pretty straightforward, map over the lines. But the line component itself, it first has to grab the right circle from the collection, and then it can do its drawing. Oh, yeah, so. Woo. And so you can see that it works. So if I move a circle around, then the lines move with it. So those changes all propagate nicely. Cool. And now this might kind of fail by not doing it on my own laptop. But if you go to the development tools. Okay, so here's something interesting. If you click that button and you highlight the updates, let's see what happens. Okay, it goes totally wild. If I drag one of these bruises, basically all of my application starts to re-render. And actually, it might now crash the DevTools. There's too many bruises in this window. Quickly, go away. And so, at this point, it's like, why is it re-rendering all of the application? And here's the answer. So, let's go back to this concept again. So again, we moved the state up. We moved the circles up, we moved the lines up. And from there on, actually not all the application was redrawing. All the circles that weren't moved, they still stayed in place. The problem was that all the lines are redrawing. Why? Because by adding a circle, we modified the circles collection. That collection needs to be passed down to the lines, but to all of the lines, because it might be their circle that was affected. So we see all those lines going totally crazy. Can we fix that? Yes, of course we can fix this. So we can make memo a little bit smarter, and we say like, hey, let's do a little bit more intelligent thing. Let's specify exactly when you need to redraw. So we can say like, if previous line object is the same as the next line object and the circles they are pointing to are also still the same, then we can bail out. Now this works and this does solve the problem. However, the problem I have is that me and my computer, we have rules of engagement. The first one is that a video connection should work. The second one is that like, the computer is doing the dumb stuff, I'm doing the smart stuff. And if I write a component of 4 lines and then I'm writing 8 lines of optimization code, then I'm violating that rule. That's my computer's job. That should be better at it. Luckily, we can hack around this and avoid this. We could also have solved it this way. What we do is like, we make the lines component responsible for looking up the right circles. So that at least keeps things a little bit more simple. But in my opinion, now the abstraction starts to leak. Because like, why should the component that is responsible for drawing a set of lines know that it needs to look up circles? So this fixes the performance, but I don't think it's better. Anyway, if I had the demo, then I could have shown you that this solved the issue. And so then our graph looks a little bit better, because only the right line would redraw. Let's again change subject. Let's talk about external observable state. And before we do that, here's a philosopher. You know what I want to say. What is a component? There are 2 takes on it. One is, you could say, a component is a slice of application. It's a black box, self-contained concept responsible for its own state, its own side effects. And this is the take that basically any framework takes, or at least it's the concept that any framework makes it easy to take. On the other hand, you could say like a component, that's just a tiny part of my visualization, of my UI representation. But actually, if you look at my application feature-wise, I might very well use the very same feature in many different contexts. I might use it in the UI, but when I'm testing, I'm interacting with it differently. Maybe I'm packaging the logic and also using it in some other framework or on server side. And so you could also like say, well, components are just about UI, and I keep the rest, especially like the domain-specific stuff that has to be on server and such, I keep that separate. And I think that's a very interesting approach, which is especially very scalable. And so the author of XState says this about it: model and develop your application's logic as if it will be used in many different UIs. Why? Because it makes sure that you're not accidentally coupling your logic with how it's represented. And an interesting effect that has is that, like, if you're writing your unit test and you're always reasoning about components, then your unit tests start to behave like a human, like they start to click buttons and fire events and those kind of things. But if you take the other approach, then your unit tests, they start to behave like an API consumer. They're just calling your logical methods. And it might actually be the case that testing components isn't that interesting at all anymore. Anyway, so these are two entirely different philosophies. And one is not per se better than the other. But I just wanted to make you aware of this difference. Now, if you go the path of state living outside the components, so the shared state I'm talking about, how does the UI stay up to date? It doesn't know about it. The answer is, observe all the things. We started actually with the answer. So we can subscribe to changes and update the UI as a side effect, because UI is in the end a side effect. And for that, we have reactive programming. Reactive programming allows us to control side effects in a very well-controlled manner. So you could use Redux, ArcGIS, or in this case, MobX for it. So MobX, I'm not really going to explain it. There's a workshop tomorrow if you're interested. But this is the gist of it. So you have some state, you make it observable, and then you start using that state in some side effect. After that point, MobX will make sure that the side effect is executed exactly and only when relevant state did change. So that makes like the when question declarative. Back to the demo application. How do we make the state observable? Well, we just pass it through the observable function, and then we get the very same data tree back, but this time it has observable capabilities. And then our functions, they become pretty straightforward, because observable data is mutable, and that makes the mental mapping between what we're trying to achieve and what we are changing smaller. The interesting thing is then our app component then becomes stateless. Why? Because, well, we just can create a state outside the whole component tree. And we can test it and do things with it, and only then start to concern about UI. So we pass in the state, and the rest of it pretty much stays the same. The interesting thing is that, like, on our components, instead of using memo, we now start to use, so memo from React, we now start to use observer from the MobX React bindings. And what it does, it looks at your render, it tracks your render and says like, oh, in your render you are using these and these objects. These are the things I'm going to subscribe to and going to react to. And so the cool thing is that now, like, both our app and our circle and our lines component, they all become basically stateless. They just, you could read them as templates. That's basically all they are now. Now you might notice is that we went back to our naive, slow implementation of the line. Again, we are looking up the related circles in this line component. So the question is, do we again have a very slow application that is like redrawing all over the place? The answer, I could demo on my laptop, so visit me afterwards if you want to see it. But the answer is no. Actually, with these changes, only the circle and the affected line components are re-rendering. Not even the circles and the lines components are re-rendering anymore. And our state lives entirely outside the tree. And so, you might be wondering, what happened there? And so, the idea of immutable data, especially in UI, has often been that like, we can better optimize it. But that's not entirely true. So, how can we optimize render? When we started with the immutable data, we were able to memo the line because we know for sure that if the line and circles references didn't change, we know that they are deep equal. So that means that we don't need to re-render. What observer does is it also applies memo. That sounds weird because it's mutable. But it also applies autorun. That's the function that takes automatically care of side effects. And so the reasoning why this works is like, why can we memorize line? Well, because the observability guarantees something. It guarantees that like, as long as this component is receiving the very same line, the very same set of circles, well, they might have changed because they're immutable. We don't know. But if they did change, we know for sure that that autorun function would have picked that up. So we can again memo the component itself. And then there's another interesting effect. Because like if the state is immutable and you change a single circle, you also need to change the collection that contains it. And you also need to change the root state. Right? You get all those new references to new objects. And so it means that also the memoization on the parent components was invalidated, and that's why the circle component re-renders, even though it's basically the same set. However, if data is mutable and observable, it means that if a circle changes, just the circle changes. You don't need to change the set that contains them, because it's the same reference. And so the circle set isn't touched. So that means that like no memorization of any of the parents needs invalidation. So that is why mutability can actually be faster. And so once your state is external, you can also move your effects external. So that means that you can also like make those individually testable. And I think you can believe that we can do that because we can just move a function out because the wiring isn't happening in the components anymore. The interesting thing is that like this way, all our functions don't need state anymore and they don't need side effects anymore. And so there are some interesting conclusions to draw from that. So first of all, there's this philosophical question. Is a component a slice of UI or a slice of application? Secondly, it's like immutable data is, I think, always better than mutable data. It's simpler to reason about and it has interesting properties. However, if your data is intended to be stateful and your data is mutable and observable, it's both faster and more straightforward. A question I get a lot lately is like, does React still need state management solutions like Redux or MobX? And I think the answer is yes, because React hooks and context, they didn't change the capabilities of React fundamentally, they just provided a much better API. Some people concluded like, since I'm using hooks and context, I don't need Redux anymore. Well, that might be the case, but that basically means that you didn't need it before. So when do you need state management? When is it useful? First of all, the primary use case is being able to manage state outside your component tree. When is that relevant? When you have larger, more complicated apps where state is used in many different places or in different settings. So because of the decoupling, it makes both the effects and the domain state better manageable, better testable. There is, of course, in any application also like the more volatile UI-only state, like a selection in a radio button list or something. Do keep that in your components, then you can benefit from React features that improve that in the future. But the most important conclusion from this talk is like, if you need happiness, go to what's Bruce wearing today.tumblr.com and you will have a happier day. Thank you.